There will be lecture tomorrow also, Priya. So we will try to complete tomorrow. Maybe Monday I'll complete group 16. Then we're left with 17. Another 3 lectures next week. Okay, let us start. So in my last lecture, if you remember, we had stopped at what you call the preparation of oxygen. The large scale preparation of oxygen was by liquefaction of air and then fractional distillation of liquid air. This is where we stopped. Also, the another one was by electrolysis, you can get hydrogen and oxygen in a ratio of 2:1 by volume. So this is where we stopped last time. So now today we are looking at properties of dioxygen. Okay, I mean, there's some very interesting facts. What is the color of the liquid? Because oxygen, as we see it, it is colorless and tasteless. Okay, but when you liquefy it and when you what you call solidified, there is a color. Is this clear? So what we have is properties of dioxygen. Properties of dioxygen. Obviously, the first one is when we look at it, it is in the gaseous state. It is a colorless. It is a colorless, what you call odorless, tasteless gas. Odorless, tasteless gas. Okay. The second is it is sparingly soluble in water, but that sparingly soluble has a lot of what they call weightage, because that's little oxygen that is there is what is sustaining the aquatic life. If oxygen is not there, okay, the aquatic life will die. What is it that we call? You must have studied in environmental this thing science. We call this as BOD and COD. BOD is biological oxygen demand and COD is chemical oxygen demand. So when a lot of pollutant basically is let into the what you call Tavishi, good evening. Can you hear me, beta?
Yeah.
Great. So I was just started the first sentence. Okay. So I was telling that oxygen is sparingly soluble in water. Okay, up to the extent of what you call 30 ml per liter. So this what you call it is sparingly soluble in water. It is sparingly soluble in water. So it's about 30 ml per liter. Okay. See, 30 ml plus, let us keep it at this, because this value we will require for MHCET. The local exam, I told you, they ask for a lot of what you call, the questions are more from the textbook where they have factual questions. I'm not getting the word factual question. Okay. Now, this sparingly soluble is very important, I told you, for the aquatic life. If this oxygen is not there, then marine life will be endangered. How does it get endangered? What happens is, when you let off lot of what you call sewage, all biological, that sewage while rotting uses the dissolved oxygen. So that's called as BOD, biological oxygen demand. Or sometimes like tanneries, chemical companies, they let off a lot of what you call chemicals which consume the oxygen. So that will be COD, chemical oxygen demand. So generally they test for presence of amount of BOD. If the BOD is very high, demand is very high, that means highly polluted water. So that's why we have this effluent treatment plant and all that, sedimentation, and they do. There's a company in India called as WABOG, WABOG. They are expert in these kind of pollution treatment machine. You should know, because environment has become a very big issue these days. So now, the next is what? I mean, you have to be very careful. So like when we are talking about phenol, chapter of phenol, we had come to this chemical called as a trihydric phenol, which is called as pyrogalol, if you remember. Now, this pyrogalol has a capacity to absorb oxygen. So if you smell, suddenly your lung will become, what you call short of oxygen. You could have suddenly oxygen deficiency, something like that. Accident can happen. So certain chemicals, you have to be very careful because they can absorb the oxygen, So though this third point is very important, that it can be absorbed in alkaline pyrogalol. It can be absorbed. It can be absorbed in alkaline pyrogalol. So that's okay. I mean, you should understand that when you're dealing with phenolic compounds, okay, maybe you have to be careful because some of them have a tendency to just absorb oxygen. Is this clear? Then it can be liquefied, liquid oxygen. I told you the whole of, if you remember, during COVID, the second phase, we had huge oxygen deficiency. Liquid oxygen was not available. It's clear because the number of plants that we had was very less. We never imagined such something like this can happen. Okay, that's what happened. The foreign companies, especially the Germans and all, they have they send the liquid oxygen machine straight away, one which will liquefy and do fractional distillation. So it can be liquefied. Now the color is very important. It can be liquefied. It can be liquefied under pressure. I had told you, Joule-Thomson effect. You put huge pressure and allow it to come through a small orifice, adiabatic expansion. What is going to happen? It will, what do you call, liquefy. Is this clear? But if it liquefies, what is the color? It liquefies to a pale blue liquid. To a pale blue liquid. So that is very important. This can be asked because you could never imagine unless told that liquid oxygen is pale blue in color. And that is at what temperature? It is about 90.2 Kelvin. 90.2. Remember, we told you that's around 78 Kelvin nitrogen escapes, leaving behind liquid oxygen, which is about 90.2 Kelvin boiling point. And further cooling. And on further cooling, what is going to happen? It is going to be solidified as it forms a light blue solid. So this is important because you cannot imagine that what the color of solid oxygen, what is the temperature that we have? It is 54. Melting point is 54.4 Kelvin. I mean, student, because they know that oxygen is a colorless gas, they cannot imagine that the solid will be light blue in color. So that could be tricky. So you better know that. Okay, heavier than air. Okay, it is paramagnetic in nature. That is very important because it is the only one which is paramagnetic. The other elements in the elemental state are not paramagnetic, except S2. If at all it exists, then that would be paramagnetic. Others are diamagnetic. It is paramagnetic. It is paramagnetic in nature. Okay, so this goes, except oxygen, all others are diamagnetic. And why is it paramagnetic? Answer I had told you. Because when you look at the molecular orbital theory, there are two unpaired electrons present where? In the anti-bonding 2px and anti-bonding 2py orbital. Remember that statement. Dioxygen molecule is paramagnetic because it has two unpaired electrons in the anti-bonding 2px and 2py orbital. Okay, anti-bonding orbital. So take down this much and then we will come to.
Could you repeat that?
I'll repeat the sentence if you want. Oxygen, why repeat? I'll write it down here. Okay, it is paramagnetic because in the MOT diagram, molecular orbital theory diagram, what happens? Two unpaired electrons are present where? In pi star 2px and pi star 2py anti-bonding orbital. Simple, write it down. Anti-bonding orbital. I used to have a boss in my industry days, Dr. Khandelwal. He used to always say this: what is not documented is not done. If you're not written and kept it somewhere, that means you didn't do it. That is how he used to talk. So we'll write it down, put it. So this question has been asked. This can, yeah, no problem. Anytime. Swayam. Okay. Now we come to the next one. See, oxygen per se. See, oxygen helps in combustion. But oxygen itself is not very reactive. Why oxygen is not reactive? See, I always told you what's the principle of any chemical reaction? Reactant bonds have to break. Oxygen, dioxygen molecule has a very high bond dissociation energy of 493.4 kilojoule per mole. So that makes oxygen unreactive at ordinary temperature. So that is why you have to all laga some jugadu idea, high temperature, catalyst and all that to break that bond. Then only the chemical reaction takes place. So oxygen is not very reactive at room temperature. If they ask, you will say what kind of, give scientific reason. You say what kind of question they ask? We know because of oxygen burns, building fire, ho gaya, everything. Oxygen helps in combustion. Oxygen supports combustion. But technically, if you take carbon and oxygen, keep it together in a bell jar and wait, no reaction will take place between them. You have to bring the temperature to 790 degrees. At 790, last time I told you Ellingham diagram, what happens? Or the entropy change becomes delta G becomes negative, not entropy, sorry, free energy change becomes negative. And what is going to happen? Carbon now is ready for spontaneous reaction with oxygen. But the temperature is also high, no? So oxygen also reacts. So at high temperature, because the bonds have to be broken. Classic example. This is clear. Now, not much of chemical property because it's a repetition, most of it. So give scientific reason, oxygen. So we are on chemical properties. We are on chemical properties. So when we talk of chemical property, what happens is, listen carefully. First is, you have to talk about GSR means what? Give scientific reason. Oxygen is not reactive. Dioxygen, let us be very clear, more clear. Dioxygen is not reactive at room temperature. It supports combustion, but it does not react. Remember that. So reactive at room temperature. The reason is because the answer is, what will you say? The reason is dioxygen has a high bond dissociation energy. High bond dissociation energy. It has a high, how much is 495? 493, sorry. 493.4 kilojoule per mole. Okay. So what happens is, and it's quite stable at ordinary. Therefore, quite stable at ordinary temperature. Quite stable at ordinary. Then that means what? As you increase the temperature, the reactivity increases. Is this clear? Now, literally, they form oxides. They form corresponding oxides. Is clear? And most of this is a repetition. I would take only two reactions because this is again reaction with ammonia. I think this is repetition because we have already done in preparation of nitric acid. So we have reaction with hydrochloric acid. That's the only one I'll take. Reaction with HCl. So what happens is HCl plus O2, high temperature 700 Kelvin, and cuprous chloride. This is cupric, it is cupric chloride. It reacts to form 2H2O and gives Cl2 gas. Okay. Then nothing. Everything else is repeat. Okay. And then I'll come to the uses, main uses of what you call oxygen. What is it used? Essential for air, rocket fuel, oxy cylinder. metallurgical purposes and manufacture of large compounds such as phenol, sulfuric acid, nitric acid. So, I mean, you can just imagine everything oxygen is used to. Okay, I'm just reading through. So, just write down this much and then we'll come to classification of oxides. So, oxygen forms oxide. So, there are 4 types of oxide: acidic, basic, amphoteric, and neutral. We discussed that and then we talk about ozone, preparation of ozone today. Finished. Okay. Now, when we are talking about oxides, so what is the definition of oxide? What happened, Priya? So we have oxide. What is the definition of oxide? Any binary compound, binary means compound with 2 elements. It is clear. Like you have element and compound. Okay, you could have Na2CO3. So it's not a binary compound. It contains 3 elements: sodium, carbon, oxygen. But if you have cupric oxide, cuprous oxide, these are binary compounds. They got 2 compound formed by 2 elements. It is clear. So any binary compound with oxygen, so that also there is a limitation, that any binary compound with oxygen is called as oxide. So basically there are 4 types of oxides, correct? We have acidic oxide. Why are they acidic oxide? They either dissolve in water to form acid. They either dissolve in water to form acid, or they react with a base, or they react with a base. Like for example, you have P2O5 plus H2O forms what? 2HPO3, that is metaphosphoric acid. I'm not giving you SO2 plus for water H2SO3. All that is known. We are still revising on the P block element. I had told you this. It forms metaphosphoric acid. Metaphosphoric acid. Some revision of the names. Okay. Then you can have the one which is having what you call reacts with the base. No, not much. Then we have basic oxide. So, one more thing I forgot. Non-metallic oxides, second point. First point was this. I missed the second point. So, non-metallic oxides Non-metallic oxides are acidic in nature. So this is another criteria. Then we have basic oxide. So when you talk of basic oxide, they dissolve to form they dissolve to form a base or they react with acid Okay, look at this. Na2O plus H2O forms 2NaOH. Okay, now you could have something like a barium oxide. Yeah, barium oxide does form. Now barium oxide, let us say it reacts with HCl to form barium chloride. It reacts with the acid plus H2O. Then the third one that we have is amphoteric oxide. An oxide which can react with acid as well as base. Any oxide which can react with both acid and base will be an amphoteric oxide. So you have aluminium hydroxide plus water plus NaOH forms NaAlO2. NaAlO2, sodium meta-aluminate. So Al2. 1 minute. This is a mistake. 1 minute. Don't worry. Al2O3 plus NaOH plus H2O forms NaAlO2, that is sodium meta-aluminate. Sodium meta-aluminate. Then you have Al2O3 plus HCl will form AlCl3 plus H2. Okay. Then the last one is neutral oxide. Basically, it's neutral to litmus. Huh? Neutral oxide. Okay. Carbon monoxide. See, carbon dioxide will be acidic oxide. Huh? Carbon dioxide plus water will form H2CO3. It will form carbonic acid, but carbon monoxide is a neutral oxide. And then you have water, of course. That's also an oxide. Na? So there, take down. We have NO, we have done NO, N2 also. We have forgotten that. NO and N2. Okay, yeah. We saw in group 15. So that also we have to include. Finish who's on today. Pakka. tomorrow can we finish sulfur? Monday. So today and Monday we will finish 16. Then we have Monday, Wednesday, Friday, na? I think by Friday we'll finish 17. Yeah, next Sunday तक finish 17. हो जाएगा. The coming week is crucial in organic. I will finish. Priya, when you finish, you tell me. Okay. So now we come to ozone. So today we'll finish ozone. Then we'll deal with sulfur, sulfuric acid, oxy acids of sulfur, 2 lectures. Then we'll finish off. So what is ozone? Ozone is an allotropic form of, it's an allotrope of oxygen. Molecular formula O3, okay? It is a colorless, pungent gas. It has a certain pungent fishy odor. You know, I'll tell you, if you are, I mean, these days, this is being sold in the market. We also have one over here. Oh, Nikal, if you can remove. Since we have one, I can show you. See, this is what we call as air purifier. Okay, this is the old model. You get many versions of this. So what happens is from the back, here in the back, you have got a asbestos. This is the asbestos filter. It takes in the air in the room. And inside this, there are, electrical rods. I mean, some rods which are present. They convert oxygen to ozone. So if you stand near this, slight fishy odor, that odor of ozone is there. Is it clear? So all your air purifiers that is sold these days, they are actually ozonizer. They are, very small amount of ozone. They are, creating because of electrical discharge. And that increases the oxygen content of the ozone. Is not stable. It increases the oxygen content. Very relevant in today's times, because what happens is we had this partial pressure. Now in the cold season in Mumbai, at least where we are, where I am, I could be having people outside listening to the. See, what happens is in winter, because of the cold, all the poisonous gases, sulfur dioxide, all of them being heavy, what happens? They are not able to move up. So if there is more of sulfur dioxide, automatically what happens? The partial pressure of sulfur dioxide is more. So the partial pressure of oxygen is less. Total pressure, in which we have pressure, partial pressure of nitrogen, oxygen, and all the pollutants. As the pollutant partial pressure increases, oxygen partial pressure decrease. So this is the time when we find, I mean, this November, December, Jan, Feb, especially in the colder times, you will hear more of the old people, especially those suffering from diabetes and cardiac problem, conking out because oxygen. So such people should be sleeping in a room in the night with this kind of air purifier. What does it do? The asbestos and the charcoal absorbs the dust particle and the poisonous gases. And plus it is also generating more of ozone. It's a very important, what you call, piece of equipment people should invest on, especially those who are having old people at home. There's science at its best. So I mean place where I stay, I mean, in the night, I don't know what kind of smell it is. It comes from the dumping ground, actually. Dumping ground is, say, about at least 8-9 kilometers away from my house. Bro, that place must be 8-9 to 10 kilometers. But the wind brings in the night, a lot of smell. So that smell is all kinds of poisonous gases, especially sulfide. The fact that it is smelling means it is sulfide. What is it going to do? How smell, we are irritated is a different thing. It brings down the partial pressure of oxygen. Oxygen deficiency can cause a heart attack. People just, people just sit and because of oxygen, they just fall down and die like that. So whenever you hear somebody died like that, now you understand that it was because of pollution. Is it clear? So allotrope of oxygen, colorless, pungent gas. Okay, it is present above. It is present above 20 kilometers from Earth's crust. From Earth's crust. Okay, today the emphasis is more on what you call environment. So you could ask some foolish question, something like that. So it's about 20 kilometers from Earth's crust. It's called as ozonosphere. It is called as ozonosphere. Why do you need ozonosphere? The ozone produced there, the ozone produced, what does it do? It filters the ultraviolet UV rays, correct? Protecting us basically. It filters the, so what happens? Less skin cancer. So now they're saying that because of this freon gas from all these aerosols and chlorine compounds, all that fluorine compounds, the ozone layer is getting destroyed, and that's going to cause. And there's a climatic change which is very visible. Bombay is much cold this year. When Mumbai, as they say, somebody say it is not a Bombay, it is Mumbai. So Mumbai is very cold. You can see. I mean, we are facing a problem. This temperature. Mumbai was never. We had hardly 2 days of cold winter. Otherwise, we never had something like that. So these are all climatic changes, and Pakistan has become the biggest victim. They had one of the worst rains this year. Okay, and 2/3 of the country is underwater only. Anyway, no sympathies for them. This is clear. So as I was telling, Swami is laughing. See, we have lost a lot because of their actions. See, sometimes remaining quiet to a certain action of people, you're also culpable. People kept quiet. And if whatever they want to do, they did against India. So today karma catch up with you. Suffer. Is this clear? So as I was telling, that now, how is ozone produced in nature? Naturally. Naturally, ozone is produced how? Is produced by photochemical reaction. By photochemical reaction. What happens? Is clear? See, you have oxygen. Oxygen reacts with UV light. 200 to 400 is basically the spectrum UV ka. 400 to 7, I mean mota mota. 200 to 400 is UV, and then 400 to 700 will be visible, and then infrared and all that. So around 200 to what? So here exactly it is 175 nanometer, what you call wavelength. So it breaks oxygen to excited oxygen, high energy oxygen. Is clear? So this is called as excited or high energy oxygen. So what does the excited oxygen do? The excited oxygen reacts further with oxygen. It forms O atomic and oxygen. Okay. So this will be, I would say, atomic or single molecular oxygen, atomic oxygen. Now this atomic oxygen plus O2, what does it form? It forms O3, which is excited. And this excited O3, what does it do? Plus M, the nitrogen actually. And what does it form? O3. So nitrogen absorbs the excess energy and you get ozone. So please take down, this is the natural way.
Done, sir.
Okay. So now what happens? In the laboratory method, what happens in the laboratory method is, listen carefully, a slow dry current of oxygen is passed through silent electric discharge. Slow. What is silent electric discharge means what, you have two metallic electrodes between which a high potential difference is established around 10,000 volt. So that creates a silent electric discharge. Is this clear? So that's why you should never, when you have an air purifier at home and you know it is also an ozonizer, don't try to open it yourself and try to put your finger and all that, and when it is on, because there is a 10,000 volt potential difference between the two electrodes. Is this clear? That's how accidents happen. So you have slow, dry current of oxygen. Slow dry current of oxygen is passed through what? Passed through a silent electric discharge. Silent electric discharge. What is silent electric discharge? That you have got two plates with opposite A and potential difference, and the potential difference is very high, 10,000 volt. So when oxygen is passed through that, is this clear? What happens? That is called as silent electric discharge, when a chemical change will take place. Okay. Here what happens? Then oxygen gets converted into ozone. Oxygen gets converted into ozone. And remember, it's about 10%. So you have series of such ozonizers to increase the concentration. Is this clear? Then what happens is, so what is the reaction? That reaction is the fact that it's endothermic is very important. 3O2 forms 2O3. Now your delta H is what? At 298, of course. 298 Kelvin is plus 142 kilojoule per mole. This has a significance. Is this clear? Just take down this. Then when you're studying the property, we'll see the importance of this. Why is ozone unstable? It decomposes immediately to form oxygen. Answer to that we are going to give by free energy change concept. Why is the forward reaction spontaneous? Finish ozone.
Done, sir.
Okay. See now some interesting. I'm going to slowly organize all that. Okay. So what we have properties. Very important because different colors are there. So when we are talking of properties, what happens? Gaseous ozone. Gaseous ozone is what? Blue. A. Its physical property mein A. Then we have got what? Obviously liquid ozone. Liquid ozone is blue-black. Then C. What do we have? Solid ozone. Solid ozone is violet black. Believe me, this I am dictating for only one reason, is that these are kind of questions are asked in MHCET. Okay. They might ask, they have to ask some factual question. This can be a very interesting one because nobody can imagine that this is the color change. This is clear. Then what happens is,
There's a pale blue glass, right?
it is,
A pale blue glass.
it's blue only. Blue. Okay. Now, what are we talking? We're coming to a very interesting. Yeah. We are trying to answer, give scientific reason Why? Ozone is unstable. That means what is happening? O3 is easily forming, easily the forward reaction. If you remember, this delta H will be, see, O2 to O3 was endothermic. So this delta H is minus 142 kilojoule per mole. Okay. There is a increase in volume. This is 2 volume and this is 3 volume. Yes. This is 3 volume. So delta S, I'll write down properly. There is an increase in volume. So in this reaction of ozone to oxygen, there is a increase in volume. So if there's an increase in volume, delta S is greater than 0, or I can say delta S is positive. So you have this delta G is equal to delta H minus T delta S. Delta H is negative, this is negative, and delta S is positive. So what happens? Delta G is negative totally. So this reaction, delta G is negative, means what? This reaction, therefore, this reaction is spontaneous. This reaction is spontaneous. Therefore, it is unstable. Ozone is preferable to form ozone to oxygen on its own spontaneously. Why? Because delta G is negative. It's a thermodynamic answer to something. Is this clear? Then we'll come to chemical properties. Just take down this much, then we'll come to chemical properties and then call it a day.
Done, sir.
Okay. Now we come to the chemical properties. Not much. So when you're talking of chemical properties, remember first and foremost, after fluorine, fluorine is the strongest oxidizing agent. Huh? Remember that. Fluorine is the strongest oxidizing agent. So there is no other oxidizing agent which can oxidize fluorine from its compounds. Is this clear? So how the question was framed for that sentence, I'll tell you when we are doing group 17. But I'm just, enlightening you. After fluorine, ozone is a strong oxidizing agent. But one thing is, with barium peroxide, and H2O2. It acts as a reducing agent. It acts as a reducing agent. See, I've always told you, Panchabhutas, 5 such substances which can act as both oxidizing and reducing agent. Which are the Panchabhutas? One we just saw now. That is ozone, nitric oxide, group 15. Is it clear? Hydrogen peroxide, we're going to learn later. Okay, sulfur dioxide and nitrous acid, HNO2. So remember these 5. Because they ask which can act as both oxidizing as well as reducing agent. Limited number, we have only 5. Ozone, nitric oxide, sulfur dioxide, nitrous acid, and hydrogen peroxide. So remember these 5 names. They act as both oxidizing as well as, maybe it is actually acting as a reducing agent with only 2 chemicals, doesn't matter. But it does act as oxidizing as well as reducing agent. So oxidizing property. See, I mean, forget the oxidizing property business. What happens is, this oxidizing property. See, I'm trying to connect a question from ozone to mole concept. You know, how much ozone is present? How is ozone estimated? It is clear that that question is there. The theory part is over here and the calculation part is in mole concept. So I'm combining both and explaining over here. This oxidizing property is used to estimate ozone. So what happens is, ozone is passed through excess of Ki. Step 1, ozone is passed through excess Ki solution. Excess Ki solution, correct? pH, how much? It's a borate buffer. pH 9.2. Okay. So what happens? Iodine is liberated. So this iodine liberated is titrated with sodium thiosulfate. Using starch as indicator. So this is the basic as far as this chapter is concerned. Now let us write the reaction. So what happens is, first reaction A, you have ozone plus H2O plus Ki. This is a balanced reaction I'm writing, 2 Ki. So what does it form? It forms 2OH minus plus I2 plus O2. So iodine will be generated. Moment iodine is generated, add starch solution. Starch will react with iodine to form what? I mean, not react, will form blue color solution. So blue to colorless, very distinctly. Now, in the burette, what will you have? So this is in the conical flask. In the burette, you have sodium thiocyanate, so sodium thiosulfate, Na2S2O3. What is this? This is sodium, what do you call, thiosulfate. What is it going to get converted into? Na2S4O6 plus 2 NaI. So this is sodium tetrathionate. So for example, now I'll tell you. Suppose so what are we realizing from the mole concept point of view? We have O3 corresponds to I2 corresponds to 2Na2S2O3. 2Na2S2O3. Okay. Suppose we had taken iodine, which is say 20, the burette reading, let us say the burette reading is 15 ml. Let's put it like this. The burette reading, which is sodium thiosulfate Na2S2O3, is 15 ml of 0.1 molar Na2S2O3. Na2S2O3. Okay. Now what happens is, see, so you have, this is 15 into 0.1, that is 1.5 millimole. Now 1.5 millimole means this will be 0.75 millimole, because half of that, na? 1 mole of iodine corresponds to 2 moles of sodium thiosulfate. So 2 moles of whatever we have is 2 times, so half of it. That means it correct, and this is also 0.75 millimole. That means it is 0.75 into 10 raised to minus 3, or I can say it is 7.5 into 10 raised to minus 3 mole of ozone is present. Correct? If you want to convert mole into volume,
So how O3 corresponds to I2?
look at this over here. Good question. See, you had O3, 1 mole of ozone released 1 mole of iodine. That 1 mole of iodine reacted with 2 moles of sodium thiosulfate.
So we take it by the concept of mole concept.
Yes, I am discussing.
So you just take the stoichiometry.
Exactly, stoichiometry. I am discussing stoichiometry. One question. How they are asking? They will say that, say 15 ml of 0.1 molar sodium thiocyanate completely reacted with iodine formed by passing ozone. So what is the concentration of ozone? What is the volume of ozone? Something like that they will ask. So that's what I'm relating to you, that 1 mole of ozone will liberate 1 mole of iodine, which will react with 2 moles of sodium thiosulfate. Okay, so we have this value. Say 15 ml into 0.1 is 1.5 millimole. That means 0.75 millimole of iodine. That was generated by 0.75 millimole of ozone. Correct? Yes or no? That is 7.5 into 10 raised to minus 4 mole. 7.5 into 10 raised to minus 4 mole. Once you know the mole, you want to have what do you call? Volume. Mole to volume, what will you do? Multiply by 22.4 liter. Yes. So 7.5 into 10 raised to minus 4 into 22.4, that many liters. Khatam. Our answer is there. Whatever it is. I mean, I'm not calculating actually. I'm just telling you how this reaction I have never propagated by hearting. But this is one thing I would like you to by heart, or simply remember that in this reaction of estimation of ozone, 1 mole of ozone will release 1 mole of iodine, and 1 mole of iodine will require 2 moles of sodium thiosulfate for complete reaction. So once you know this, they will give you the volume of sodium thiosulfate and its molarity. So back calculate and you will find out. Multiply by 22.4. It is Avogadro's law. Is this clear? Okay. So this is about, of course, what is the uses of ozone? It protects the layer of, it is used to sterilize air and water. Yes, it is used to sterilize water. Now, you know what happens is in 5-star hotels, if you see, the membership fees is very high, or in international swimming events, they don't use chlorine to disinfect the water, they use ozone. Because if you use chlorine, it irritates the eye, and when you come out, what happens? Residual chlorine causes darkening patches of the skin. So ozone is a much better, what you call, disinfectant. It is used for as a bleaching for starch, flour, wax and all that. Toxic and used as germicide. And it is used for bleaching silk, basically. Silk, and that's the basic use. We have gone through it. So just take down this much and then you can leave the portal. So I've just discussed this question. how it has been asked. But I just took an arbitrary value 15 ml. Okay. So whatever they give, this is how you have to solve. So we will be meeting tomorrow at 5 o'clock. I'll start with sulfur tomorrow. So by Monday, I'm completing group 16. Thank you very much. What time?
So before class.
Yeah, I'll send the link 4:30. Come on. Let's see how much you can solve.
So I have to have some doubts.
The 4:30 you join, na? I will
Yes.
Others are.
Yes, sir.
Okay.